Okay, everyone. So I intended to teach this unit live. I don't really have any recordings for this. So unfortunately, I will not be able to be at school the day when you are doing this lesson. So I decided instead of us falling behind, that to do this recording for us. Okay, so this is just an introduction unit to space, or essentially Earth and space science. And honestly, a lot of this is just going through different definitions, different terminologies, and starting in the continuing lessons after this, we will go into more details about some of the things we're touching upon briefly today. Okay, so just a few definitions to start. So first of all, a lot of people get astronomy and astrology mixed up. So astronomy is exactly what we're going to be doing. So it's the study of what is in space beyond Earth, so beyond our planet. So this can be other planets, of course, this can be our solar system or beyond. So it's essentially a science that's based on evidence. Astrology, however, is looking at celestial bodies, so different things that are found in the night sky, and seeing if that essentially has an effect on human behavior. So this would be, if you look up your astrological sign, someone says they're a Leo or a Capricorn or a Libra. That's astrology, right? So maybe you've seen that in the newspaper or online somewhere where they say, what is your day going to be like today if you are, a Taurus, for example. Okay, so it's based on belief and not necessarily scientific evidence. Okay. So constellation is essentially a group of stars that seem to form certain shapes or patterns in the night sky. Okay, so for example, the Big Dipper is a very common example of that. But actually, the Big Dipper is a smaller portion of a larger constellation called the Ursa Major. So if you look in this picture here, or this is the Ursa Major, or in other words, the Great Bear. The Big Dipper is within it. So you can see this, it's highlighted in like the darker, like there's white lines, but it's more of a bold white line. So that is actually embedded within a larger constellation. So constellation is usually a grouping of stars. They can be small or they can be large, have many stars in it or few stars, but essentially that's what a constellation is. Now, of course, this is where, in past history, this would be used, the movement of the stars, which was essentially the movement of the Earth with our rotation, people would use this as direction or keeping track of different timelines, right? So looking at the movement of stars, they would believe, okay, well, it's been 1 year, let's just say, because the constellation has moved from this location to this location. So this was obviously before we had traditional calendars and timings as we have today, right? So this is more historical wise. Okay, so then we have something that's called luminous versus non-luminous. So an item that's in the night sky that is luminous is something that gives off its own light, okay, which is really only a star. So for example, the star that is in our solar system, the only one that is our sun. So typically solar systems have a star in the center of it, or sometimes multiple stars. But the star is giving off its own light. Okay, so how it does that, we'll go into more detail when we learn about the sun. But essentially, it is a nuclear reaction where you have nuclear fusion happening between hydrogen gas, hydrogen atoms, I should say, that are fusing together to make helium. So that lets off a ton of energy, both light energy, and of course, we know we get a lot of our heat from our sun as well. So anything that you see that is not a star is actually because it is a non-luminous object. So meaning we see those items because light is reflecting from the sun onto the surface of other objects. So for example, our moon or other moons or other planets, asteroids, comets. So we're only able to see all of these other objects because of reflected light. Okay, so a lot of people believe that, for example, the moon at night, is providing its own light, and actually it's not. We see the moon because of reflection. So again, this is a little introduction lesson. We're going to spend time talking about the moon specifically on another lesson. Okay, so an asteroid really has a wide variety of sizes that it can come in, but essentially it's a small rocky object, or essentially a rocky object that never truly formed into a planet. So meaning it does not have its own gravitational pull. So there are many different sizings, like I mentioned, and actually there are lots of asteroids all throughout our solar system. But majority of the asteroids are found within this asteroid belt. So it's found in between Mars and Jupiter, which is really this separation between the inner planets, which are also called rocky planets, versus the outer planets, which are sometimes referred to as gaseous planets. So in between the rocky and gaseous planets, which is Mars is the end of the rocky planets, Jupiter is the start of the gaseous, we have tons of asteroids, like thousands and thousands of asteroids that are seen there, that are orbiting the sun. Okay, so this is just to show you, an example. Obviously, this is not a realistic picture. It's actually a computer-generated probability chart. So meaning they kind of mapped out based on pictures that have been taken with some telescopes. Where do they believe majority of the asteroids are essentially where all of the white dots are that you see here. Okay, so you can see from the planet orientation, right? So here's Earth, and then Mars, and then Jupiter is quite a ways away, distance-wise, but in between is where you have a lot. So you still have asteroids, of course, closer to the sun than where Mars is, but it's not as frequent as this location. Okay, so then we have meteors and then meteorites, or sometimes we can also say meteoroid. Okay, so the terminology, they're all kind of the same thing, okay, but the terminology changes depending on what is happening. So a meteoroid is a lump of rock or metal, okay, but it could be a mixture of rock and metal. Most of the meteoroids that exist are incredibly small, okay, so sometimes as small as a grain of sand. But some can be huge, okay, like the size of a really big boulder. So, again, they kind of vary in size. So it's hard to kind of, define it as being, a meteorite is always, 1 meter in length. Well, that's not true. It comes in a wide variety. A lot of the things that are out in space, such as asteroid, comet, meteors, those are all sometimes defined by the components that they're made of, right? So asteroids are just rock. Meteoroids are rock and metal mixtures. So when a meteoroid enters Earth's atmosphere, what ends up happening is the meteor will begin to look as if it's glowing. Okay, so what's happening is the friction that is caused by the atmospheric particles and the actual meteoroid itself is causing it to warm up, right? So similar to if you were to do friction with your hands become warmer. The same thing is happening here. So it seems as if it's essentially burning up. So now, when we have this process happening, when it is in Earth's atmosphere, we call it a meteor. So in outer space or outside of Earth's atmosphere, it is called a meteoroid. As soon as it enters into Earth's atmosphere, it is called a meteor, or sometimes you refer to this as a shooting star. Okay, so a lot of the times people think that shooting stars are comets, but actually comets are typically very, very far away. You'd only be able to see it truly with a telescope. So if you're looking into the night sky with your naked eye, just looking up, and you happen to see a shooting star, maybe if you've gone camping or whatnot, that is more than likely a meteor. Okay, so once it actually hits the Earth's surface, usually it's much smaller than it was when it entered Earth's atmosphere. Because as it comes in and it starts to burn up, chunks of it essentially tend to kind of fly and break off of this meteor. So what ends up happening is you have a very small piece of rock metal that hits the Earth's surface, and we now call this a meteorite. Okay, so let's recap that. So it's a meteoroid when it's out of Earth's atmosphere. It is a meteor in Earth's atmosphere, and it is a meteorite once it has reached Earth's surface. So actually, I like these two pictures here because you can see the difference between two examples of meteorites. So we can have ones that are very small. So this is just a small coin. It's an American coin. I don't know if it's a penny or if it's a dime, but it's very small, right? So comparisons to the one that you see here on the right-hand side, which is ginormous, okay? So obviously, this can range from nothing, like no disturbance whatsoever, and also a lot of the times these meteorites end up hitting the open ocean, right? So a lot of our planet is open water. So we wouldn't even have noticed really if it's coming down onto the Earth's surface. However, of course, like this one on the right, I'm sure that this caused a lot of destruction for the town or the village. Obviously, this was a long time ago. They've built kind of a little theater style seating around it. So the destruction level can really go from really nothing to obviously causing quite a big disruptance. Okay, so comets. Let's talk about comets now. So comets, so remember I was mentioning that each item is kind of made up of a different structure. So comets typically have a combination of rock, dust, and ice. Okay, so it's very cold in outer space. So essentially, if there is any water components out there, they are for sure in the frozen state, right? It's below zero. So yes, you have a mixture of the two. So let's remember we talked about asteroid is rock. Your meteoroid is going to be rock and metal. And then the comet is rock, dust, and ice. Okay, so when you're looking at a comet or you see pictures of comets, they always look like they kind of have like a little sphere with almost like a tail coming off the other end. Okay, so that tail, just so you know, is actually essentially there are compounds that are breaking off of the comet that contain ions. And when the ions interact with the energy from the sun, essentially, they have a specific color that it will turn, or you'll see this like glowing happening. So one thing to keep in mind is they're very, very long, right? It may not look like it's long, but this can be literally millions of miles behind it. So it looks like it's, obviously it looks kind of long, but you can't tell the difference in distance from an image like this. They're incredibly long. The other thing to remember is that they will travel around the sun in orbits. And how they do that is actually in elliptical patterns. So not in perfect circles, but actually almost like an oval shape. Okay. So they travel around the sun. So the tail is always pointing away from the sun. So it's like imagine the sun would be right here, and the comet is always going towards it in an elliptical fashion. All right, so we'll go to the next part for the remainder of this.